Okay, students. So our today's topic is related to the force vector directed towards basically along the line. You can say this. So let's move in that direction. If you remember yesterday, what I have done, I have discussed basically that what is position vector, right? Position vector, if you remember, was something like this. Think of that we are looking into this is the axis x, y, z. There is a point somewhere here, right? If you remember, we discussed this thing. So if I say that in order to reach this point A, for example, I moved in x, let's say 2 units, I moved in y, let's say 4 units, I moved in z, let's say 5 units. The coordinates for this thing is 2, 4, and 5, right? And when I want to make a vector, so from 0, this is 0, let's say, 0 to A, I will write this vector as 2i plus 4j plus 5k, right? So using the coordinate of any point, what I can do, I can make the unit, position vector, right? Then once I know this vector, I can also know that what is the unit vector for this, like what is the direction for this one, right? So you remember that if there is a vector, let's say RA, this is the vector 2i plus 4j plus 5k. How can I calculate the unit vector for this one? Do you remember the procedure? If I want to know what is the unit vector RA, what should I do?
Find the magnitude first.
Find the magnitude. So I will first figure out what is the magnitude of this. It would be under root 2 square plus 4 square plus 5 square, right? So just have a quick calculation. Just see how much is it. I'm just using the numbers here so that it's easy to calculate.
3 square root 1.
How much?
3 square root 1.
3 square root. So what would be in decimal?
Decimal is 6.7.
6.7. Okay. So this is the magnitude. Then what I do, I would say 2 over 6.7i plus 4 over 6.7j plus 5 over 6.7k. This is the unit vector, right? If I want to know what is the direction, this is the unit vector. Now think of a same scenario. This is point A, this is point B, you know their location, you know what is x, y, z, you know what is xa, you know what is ya, what is za, and you also know the location, what is xb, what is yb, and what is zb. So if you know these two, you can use this formulation, right? And you can calculate what is the position vector r, right? It is, you remember we took it, it's final minus initial. So if I want to calculate R, A, and B, that would be XB minus XA I plus YB minus YAJ plus ZB minus ZAK, right? This is the position vector. And then if I want to take the unit vector, I will call it unit vector by dividing the whole thing with the magnitude, right? So whatever is here, xb minus a, whatever is this, I will take square plus yb minus ya, whatever is this value, like here you have the values, but I'm just writing it as it is, xb, zb minus za square. So I will convert this into the unit vector direction. So I know basically that what is the direction, what is the unit vector in this direction, right? Now think of if I say that I am pulling this with a force 100 Newton. If I know the unit vector and if I know the magnitude 100, I just simply multiply 100 with this unit vector and I can convert it like a force.
Yeah.
right? So this is the advantage, that whenever we have a position vectors, we can calculate unit vectors out of it and use these directions for the forces. So I can construct the force vector. If I do not know the alpha, beta, gamma, or theta or phi for the force, I can calculate like this, right? So this is the main idea related to that one. Now we'll take some practical cases. So think of, this is a scenario where a man is shown and it pulls on a cord, with a force of 70 pound. This is the British units. So it's like 70 Newton in SI. Newton is equivalent to pounds if you are using British system, right? So it's putting that with the magnitude, force magnitude of 70 pound. And you need to represent this force that acting on the support A as a Cartesian vector. So it's very similar that this location, this location, it's going like this, and the force which is acting here is 70. So I can use these positions, A and B, I can use these positions, calculate what is the position vector first, then I will calculate what is the direction of this, and then I use this direction and the force together, right? I will add them together and I will use them together, and I can not add, in fact, it's just multiplication, but I will use them together, you can say that, and I can figure out that what is the force, what is Fxi, what is Yj, what is Fz. So my ultimate goal is to construct like that. This is called as Cartesian vectors. Okay. This is something what we do. So please come time. The class starts late. Otherwise, we would take any mark absent. So students, this is one thing. Can you give it a shot at your own to first calculate what is the position vector? Okay. And I can tell you one thing which is easier. Origin is your own choice. Like one thing is you can take this as an origin, 0, 0, 0, origin. So you will know what is the coordinates here, what are the coordinates here, A and B, and then use the formula. XB minus XA plus YB minus YA, final minus initial. There is an easier version as well that maybe you can shift this origin here. So if I show you, I can mark this as an origin. I can say that this is origin for me, right? So thing will be easier for me because then one of the point is 0, 0. Initial is 0, 0. Only final is 0, right? So if think that origin, this is 0, 0, what would be the location of point B? What should I write? X, Y, and Z if I use this origin? Think and then tell me. In order to reach from the origin to this point B, how many X units I need to walk, let's say. So I'll use this in red color, for example. If I am standing here at origin and I need to reach here in X direction, how many units I need to walk? X direction is this one, right? This is X direction.
So I think they will always stay the same, but the Z will change.
That's true. So think it like that this is 12, right? It means that I need to move 12 units in X like this. Then how much I need to move in Y? So here you can see Y is written like 8, right? So this is 8 provided, which means I need to move like this 8 units. And then how much I need to move in Z to reach that point? So if I change again color for this representation, let's say this one, I need to move down. This is written 30, like this, right? So let me make it a little easier to work with. So I will first move like this 12 units, then I will move like this 8 units, and then I will move like this. So 12 is for X, 8 is for Y, and 30 is for Z. But it's not 30 if you see, because 30 is from here to the floor. I need to reach this height.
30 minus 6.
30 minus. So technically it is 30 minus 6. So this z should be equal to 24. So what is the coordinate here? Then 12 plus 8 or minus 8? Is it towards positive y or negative y? Minus 8. And then z is plus 24 or minus 24? Downward is minus. Yes, so it's minus 24. So now this is the final coordinate. Initial I said is 0, 0, 0, right? I use this origin. So you know that it is always when you want to write like from A to B, it is always final minus initial, right? So you can write 12 minus 0 for x, this one x, and this one is x, 12 minus 0 I. Then plus you can say that minus 8 minus 0 j, right? This is the final y, this is the initial y 0. Then you can say that minus 24 minus 0, this is k. So this is in the final k, final z, this is initial z. So the position vector would be equal to 12i, right? Minus 8j minus 24k. Now, the advantage of using this as origin is that you can see that once you know this, you can just simply write it like position. Because initial are 0, right? If I have some initial other values, then they will be subtracted, right? Otherwise, you're subtracting 0. So you can just simply make this and just simply rewrite it. Besides going to this step, you can skip this step and you from here you directly know it's step. This way. Okay? So this is something that you need to keep in mind. Can you tell me what would be the magnitude now? Because I want to know the unit vector for this. If there is a vector RAB, you know that it has first magnitude and it has this unit vector. So I am interested in the unit vector. How can I calculate unit vector? This vector I have already, I'm aware, this is the vector. I just simply divide this thing by what? By the magnitude, right? So I will divide both sides by magnitude, and if I know the magnitude, I can calculate the unit vector. You know this thing, right? I'll erase some portion from here. This got erased all the way. Do you know how can I get it back? No. Anyway, it's here, so I'll use this one. So we have developed this one, right? RAB. 12i 8 minus 8j. Now I will take the magnitude for this one. So magnitude is nothing, it's just the square root of 12 square minus 8 square minus 24 square, right? So minus sign when you take square will become positive. In the end, you're adding all these three, right? So it will become 28. And in order to get the unit vector RAB, you are dividing this vector with this one, right? So it will be 12 over 28i minus 8 over 28j minus 24 over 28k, right? This is the unit vector. What did I tell you? If I know the unit vector and if I know the force, if I know what is the unit vector RAB, and if I know the force 70 pound is acting, I can convert this 70 pound of magnitude into a vector, right? So I can use the same vector, which is unit direction vector, for the force, because force is also in the same direction. Yes. So when I want to know the force vector, I will just simply say 70 multiplied by 12 over 28i minus 70 multiplied by 8 over 28j minus 70 multiplied by 24 over 28. I just simply multiplied this magnitude 70, right? So when you solve this one, This is now the force vector. The question is asking you to represent the force as a Cartesian vector, right? And you also need to show the directions, which means you need to know the alpha, beta, gamma for this force. So can you give me the numbers? Can you multiply 17 into 12 over 28? So I want to write what is the force vector, how it will look like.
First one is 30.
First one is 30, okay. 30i, then
Negative 20.
minus 20, j,
Negative 60.
minus 60. Okay. So this is the force vector. So we know this force vector now, Cartesian vector, right? Now I need to know the unit vectors. The direction for that one, which means I need to calculate alpha, beta, and gamma for this one. So how do we calculate alpha, beta, and gamma? Do you remember? We already know the unit vector, right? This we already know. If you remember, we know that this portion is equal to cos alpha square, right? This one we know that is equal to cos square beta. This one is equal to, we know that cos square gamma, right? So we know that that this is already there. In fact, I think it was not square. Here you have used the only this one, so you can see that it's not square. Sorry, this was identity that was equal to 1. This is equal to cos alpha. This is equal to cos gamma, cos beta, and this is equal to cos gamma. So if you see, I can build the vector, which is this vector, the one you have created, right? And then I am using this as a cos alpha, 12 over 28, cos beta, minus 8 over 28, because you have the unit vector, right? This is just the unit vector. So we know that unit vector is equal to these ones. Cos gamma is equal to minus 24 over 8. So when you take cos inverse on the other side, you know what is alpha. Try figuring out what's the value. Minus 8 over 28 and keep the minus sign there.
This one is 64.6.
64.6. 64.6.
The second one is 106.6.
106.6.
And the last 148.99.
48.
148.
140. Okay, that is. So if I show you the values, yes, right? Yes, students, make sense? If you see, these are the numbers that you are getting, right? Now, this is how it would look like, by the way. If you draw from the origin, this vector alpha, beta, and gamma will look like this.
You have to draw the.
It's better, yes. So you know that alpha is 64, which means that if you, this is x, this is y, this is z. So beta angle is more than 90 and gamma angle is more than 90 as well, right? So it means that this will go somewhere here, beta, right? This will go somewhere here. So it will be basically on the other side of the x, basically, like, like in this direction. This is minus y, this is minus z. So it is kind of downward going like this, right? And this angle is, let's say, 65. So this is how, if you can see, it looks like, something like that. It's 3D, so orientation will be very similar, almost the one I have shown, but it's 3D, so that's why it's there. It will not be on this side in this portion because it's more than 90. If it's less than 90, beta is less than 90, then it is on this side of the x-axis, right? On the right side of the, it would be on this side. But when it's more than 90, then it is on the other side of the x-axis. Similarly, if gamma is above 90, so this will be moving upward. This will be in this region, right? Like you can see, this is 90, so this force direction will be upward if gamma is less than 90. But it's more than 90, so it's going downward. That's why this direction is downward. And x is less than 90, so x is fine in this case. Make sense, students? Okay. Another similar question, right? But there is one trick here. That trick is that again you need to represent the force as Cartesian. You know, like you need to write like this. The same thing we did before. You need to represent force like this. The only issue is that you have the value here, you know what is the coordinate here. But for B, they didn't give you x, y, z directly. They have given you these values. They have told you that for point B, this is like 5 units, right? And then they have given you, let's say, let me erase this so you can see. And then they have given you not the angle, they didn't give you this angle. You know, they have given you this small triangle. I told you that when they give you small triangle like this one, 3, 4, 5, and this theta is not provided, what you do, you just put the definition of cos theta. So for example, when you want to use this side, like cos theta, you will call it as 4/5, right? You will use this ratio. When you want to use this side, that is the sine theta, you just use the ratio 3/5. So you can use, instead of sine theta, this ratio 3/5 from the triangle, because cos theta is base, this is base, and this is hypotenuse, right? So cos theta is base over hypotenuse, 4/5. So if I do not know the angle, I can use this equivalent ratio, right? Sometimes they give you triangle like that. It means that you can, instead of using cos theta, you can use the actual ratio, right? So students, now think of this part. So this is 5, this side is 5. If I want to know how much is this length, what would be this length? 5 times cos theta or sin theta? It's 5 cos theta or sin theta? Cos theta, yes. But I do not know the value of cos theta, I know the ratio. So I can write 5 times 4/5, right? So this side is equal to 5 times 4/5, right? What would be this side? 5 times sin theta, right? So I do not know what is sin theta, but I know the ratio. So I will write it 5 is equal to 5 times 3/5, right? Make sense?
Yes,
Okay. So this is slightly tricky. Why? I will tell you, because if you see here, let me erase this thing a little. I know this side here. I know this side is this, right? So I know this is representing Z right now, right? And then I know the other one which is in the middle. So how do I translate this thing for the x-axis and y-axis? Because I need, it's like this. There is x here and there is y here, minus x here and like positive x. This is in the middle like this. The magnitude of this thing is 4/5 into 5, right? And you know this angle. So how do I use this for the x-axis and y-axis? I will solve another triangle. I will make this triangle. This is for x, right? And this is for y. Right? So what should I write for x? 4 over 5 times 5, like this is the hypotenuse value, into cos 30 or sin 30 for x.
Cosine theta.
Or sin 30. Yes. And then for y, I will write 4 over 5 into 5 sin 30, right? So in order to get the value here, I need to solve this for x, this would be the x. I need to solve this complete for y, right? And z I know, this is equal to z. So I need